All right, welcome. Let's work number 2 from the Calculus BC exam from this year, from 2023. So this is a parametric equation situation, and they're showing us the path the particle is moving along, and x of t is not explicitly given, but I guess we can see where x starts and ends, and y of t is 2 sine t. But they did give us dx dt. And that's something that we're not going to be able to take the antiderivative by hand, but we've got a calculator, so we should be able to work with this. All right, we're going to find the acceleration vector of the particle at time t equals 1. Show the setup for your calculations. That's a new prompt that I'm not familiar with, but hopefully you just read it like my students said. They were like, I just figured that meant like show your work, which is, I'm sure that's all it means. So I'm going to go over here, and for part A, we're going to need x double prime and y double prime, because that's acceleration. So I'm going to say, for A, x double prime of 1 and y double prime of 1. This is what they're talking about when they say show the setup for your calculations. We don't have to do anything else because we're going to use the calculator to find this derivative. Okay, me personally, I'm going to be putting dx dt into y1. So e to the cosine t. And okay, as soon as you hit a trig button, you should make sure you're in radian mode. And then dy dt, I think I'm going to need to take that by hand, but I don't think it's going to be too hard. It's going to be 2 cosine t. And in my class, I always encourage people to start by putting dx dt into y1, dy dt into y2, and y3 equals y1 squared plus y2 squared. Actually, the square root of that, pardon me, because this is for the speed. So the square root of y1 squared plus it's going to be y2 squared. And I know this problem does have a speed component on it, so I'm going to need that eventually. And it has a total distance, so I'm going to use y3 a couple of times. Okay, but for now, I just need x double prime and y double prime, so that's going to involve taking the derivative of y1 at x equals 1. It's negative 1.444. I don't know if you can see that. There's pretty bad glare here. But it's just pretty standard math aid on the calculator. Okay, and then we're going to do the same thing, but for y2. Yeah, you can still see that. So I'm going to go over here, and I'm just going to change y1 to y2. And negative 1.683. And that's A. For part B, we're going to find the first time t at which the speed of the particle is 1.5. Okay, and they probably they give us a time interval this thing's moving on, 0 to pi. So I'm going to make sure to set my window, accordingly when I go to solve this thing by graphing. So I need to find the speed equals 1.5. And if I'm going to solve an equation using the calculator, I need to write down the equation that I solved. Right, so x prime of t plus y prime of t equals x prime of t squared, plus y prime of t squared. Square rooted, that needs to equal 1.5. That's the equation that we're solving. Okay, its speed equals 1.5. So I'm going to go in here, and I'm going to turn off the graphing of these two things, because I don't really need to see those anymore. I'm going to go over here so it's not under so much glare. Okay, now it is graphing y3, and I'm going to graph y4 as 1.5 and see where they intersect on the interval 0 to pi. Okay. So it looks like the black curve is going to be speed. I don't know why, but this calculator just graphs so slowly. I've got another one that I was using. It seemed to graph a little faster, but then I loaned it to somebody for the AP exam. They haven't given it back to me yet. Worse, it wasn't even a student in my own class. So, okay, there we go. There's the first time. There's the second time. Okay, so there's 2 times. I'm just going to calculate an intersection between black and pink. I'm going to scroll over with my guess, so I'm really close to the first one, and then it gives me 1.254. I'm not sure if that's clear enough, but that gives me t equals 1.254. Always 3 decimals in AP Calculus. All right, find the slope of the line tangent to the path of the particle at t equals 1. Find the x-coordinate of the particle at time t equals 1. Okay, both then 1. It seems like 2 parts. Show the work that leads to my answers. Okay, sure. Okay, so the slope of the tangent line. You know what I was thinking? I'm going to hold on for a second. I don't think this is actually going to matter. I mean, but we don't know the scoring guidelines yet. But since y prime is not explicitly given, I'm going to just write down, hey, I know that y prime of t is equal to 2 cosine t. I don't think this would be necessary because you can actually have the calculator take the derivative for you at each point. But I just, can't be too safe. Free response. We budget 15 minutes for free response question. I'm only sitting here at 5 minutes, so I've got plenty of time. And then part C is going to be, all right, so dy dx at t equals 1. Okay, remember, I don't know if you looked at the scoring guidelines from last year, but we did in my class, and because I scored the parametric problem last year, and there was this big issue where a lot of people lost credit for saying function was equal to a constant. So basically saying dy dx equal to a number. That's not always true, right? Dy dx at t equals 1 is going to be a number. So that'll be the derivative of y with respect to t at t equals 1 divided by the derivative of x with respect to t at t equals 1. And I'm going to have the calculator do this. Okay, remember that y prime and x prime are loaded into the calculator already as y1 and y2. So all I need is a fraction, okay, y2, that's dy dt at t equals 1, divided by y1 dx dt at t equals 1. And I get 0.629 or 0.630. And then find the x-coordinate of the position of the particle at t equals 1. Well, that's x of 1, and they already gave me x of 0 up here at time t equals 0. The position is 1. So x of 1 equals x of 0 plus the integral from 0 to 1 of the derivative of x. And so, okay, x of 0 is 1. 1 plus the integral from 0 to 1 of x prime is e to the cosine t dt, and don't try to be a hero and anti-differentiate that thing. It doesn't have a closed form antiderivative. So what I'm going to do is I'm going to say 1 plus the integral from 0 up to 1 of dx dt is y1. Just triple check that. No, I don't want to be wrong. Yeah. y1 dt, and let it think for a second. I get 3.342. And then part D of this problem is just going to ask the total distance traveled by the particle over the time interval 0 to pi. Show the setup for my calculations. Maybe that's just like, make sure you're showing what you are doing on the calculator. But that's not something that people in my class have historically struggled with. Okay, integral from 0 to pi of, okay, speed gives me total distance. So let's say that'll be x prime of t squared plus y prime of t squared dt, and then that's where I'm going to integrate y3, because I've already got speed entered as y3. So I'm going to call for an integral from 0 up to pi of y3, which did, go back and remind you, that's dx dt squared plus dy dt squared. So we're going to go over here, press enter, let it think for a second. That always takes a while. And I get 6.035. Okay, so there you go. There was BC number 2 solved for you. Thanks for watching.